Hi, in this video we're going to use the Spring Boot framework using MongoDB. So this video is part of a bigger course, which is web development using Java and the Spring Boot framework. My name is Shad Sluter and I'm a professor of software development, and I'm glad you're here to join us. This course has a whole bunch of pieces and we are on part 5. As you can see in the previous lessons, we've built an application, we've connected to a database, which is MySQL. In this video, we're going to transition the same application into MongoDB. Let's take a look at where we've been. So there's a front end, and then there's a whole bunch of layers to our application, and at the bottom, we built a MySQL database. Now what we're going to do here is we are going to do a replacement, which is going to take out the MySQL database and put in a MongoDB. So now we can do requests and responses using the same architecture on the top layers. We're just going to change out the bottom layer. So when we're done with this, we will have the same application that we did before, but with a minor change. We're going to have the MongoDB as the data source. Notice the ID values in the left column. These are strings that are the type of data that Mongo uses rather than integers, which you would find in a typical SQL database. The same will hold true for our single page application that we built before. You can see that the same response and the same behavior is there. We just have different ID values than we did before. Let's talk for a minute about the differences between MySQL and MongoDB. So just in the next minute, I'm going to show you some differences, but if you really want to understand them, then I'll suggest a different course, which is my course on database management. And you can see lots of practical examples on how to use these two tools. Notice first of all, the primary difference that you'll notice is that SQL databases work with tables, very structured design. And in Mongo and other NoSQL databases, you have things that are basically large JSON objects. They can be flexible, they're unstructured, you can add items to them. Not every record in the database has to be identical. And so it's more like a big text file rather than a list of things in a table. So that is the primary difference that most people would see in the two databases. Also, you would find that when you try to access data, you have a very different experience. So SQL is an entire language that people learn to do queries such as selects and inserts and deletes. Now in the Mongo searches, you have to be able to form these JSON formatted queries. So you can see that the same concepts apply here, it's just a different syntax. But the database management system will reply with search results or will perform inserts or deletes, just like all the operations that you would need in a Mongo database. One difference that you'll notice between these is that SQL databases are rather monolithic. That means that they work really well on a single server. If you need a bigger database, you just add more memory, more hard drives, and then you have more data. However, eventually you'll outgrow a single server if you have a large-scale app. And so then you start doing shards. Now you can split up tables and SQL databases into shards. However, it's not nearly as easy as if you were to do it in a NoSQL database. And so that was one of the primary reasons why people built Mongo or other NoSQL database is that you can have them split across servers, across time zones, and then the responses can be scaled much better. The final difference that I'm going to point out here is what's the difference of how you handle data. In SQL, you have multiple tables, and if you want to combine them, you perform a join. So for instance, if we wanted to have orders and the customers to be merged into a single query, such as orders by customer name, you could select certain items out of each table and produce a new query. So we have very efficient use of space. No data in a database in a SQL table should be duplicated. You should have one unique value for each record. So in MongoDB and other NoSQL databases, you would have a lot of duplicate data. So for example, if you wanted to have a record of all orders by users, you would create a JSON object like this one, and it would be the name of the user at the top and then a subproperty, which would be an array of orders. You might have another collection of orders in another context, and so each order would have duplicate data. And so if you've learned the rules of how to build a SQL database, then you have to unlearn them all for NoSQL databases. So they work quite differently in the philosophy of how they manage data and store data. So you could argue that a NoSQL database is very inefficient in how it uses space. However, it is more efficient when it comes to making queries because there's no joining processes going on. So your server load on your processor might be lower, even though you may have more space on the hard drive. So for this tutorial, we have 5 steps that we're going to do. And so we'll get to that in just a second, but let's lay out what we're going to create. So first of all, we're going to create a database. We're going to use the Atlas system, which is an online source of MongoDB. You can set it up for free. So really nothing to install on your computer. We just have to have a connection to make sure that we can talk to it. We're going to install some dependencies in our Java application, so we'll modify the POM file with this library right here. Then we're going to define a data source, and so you can see a connection string tells us that we go to a Mongo server, put in a username, password, and tell us which tables we want to access, and then magically the driver in the dependency is able to talk to that server. We're going to set up a repository, and so just like we had a repository for our SQL server, we don't have to write any queries except for in custom cases. So things like find one and delete one and search for all, those are all going to be predefined for us, so we have a very simple process when we use the repository pattern. We're also going to have a new item in our configuration of our app to tell us that we are using a new data source. When we're done doing all these configurations, we'll get back to the same application we have before, except we'll be talking to a different set of data. So let's get started with the code. Okay, so the first thing we need to do to make our application work is set up a MongoDB instance. So I'm at mongodb.com and I'm going to sign in, and then we're going to create a database and fill it with some records, so that way we have something for our app to talk to. All right, so the easiest way to do this is to use your Google account and sign in. So I have some photos here that I'm going to share with you of screen captures that I took as I was setting up my database. So that way, if you follow these, you'll get to the same place I am. I'm going to go rather quickly because I want to keep the video short. First, you'll be presented with a login screen, so either use your Google account or set one up. Secondly, you're going to have to set up an organization. So I am calling mine amazingadventures.org, so name yours whatever you like. And then you have to create a database instance to go along with that. So my project that I'm creating is called CST339. So that's just a code that I use for the class that I teach, and you can use whatever name you like. So call it my Java web app or anything that you choose. The next thing you do is you're presented with a language, and of course we're working with Java, so select Java and click Continue. However, you can see that many languages can talk to a MongoDB. Then we're going to choose the free plan. So at Atlas, we have the option of having these worldwide scalable applications, and the free plan is good enough for making our own student websites. So pick the free option. When you set it up, you're going to be asked where you're hosting this. So I'm going to pick AWS and pick the region that is closest to me. I live in Arizona, and it looks like Oregon is considered close, or at least we're in the same time zone for half the year. Once you've got your new database set up, you should be able to have cluster 0 available. Now we want to be able to make a new collection, so we're going to create a collection that will allow us to add records. Then we can explore the data that we put into it. So you can see that the database that I'm using is called CST339, and then the collection name. Now a collection is the same as the idea of a table in a database. So I'm going to have an orders collection right now. Later on we'll add a users collection, and then we'll be able to merge the two together. So make a collection called orders. Once you have your new collection, you should be able to see it in your collections that says, hey, you've got a new orders table essentially. Now there's no data in it yet, but we can choose the insert button and we can start adding some. But we'll get back to that in a minute. We need to give access to our database. So let's click on Database Access under Security, and we want to add a user. So that way we can log in with our application and communicate with the MongoDB. So create a user. I'm going to set one up called Database User, give it a password, and none of the other items that we're going to pick right now. We're just going to go straight password. It's the simplest of the 3 choices you see here. Then finally, we're going to have the user privileges. So we're going to be able to read and write to it. So that way we can do our full CRUD applications. Next, we need to set up a network access. So that way you can have sites on the internet that are authorized to connect to this database. So this is an important security item. You don't want everybody in the world connecting to your database, just the IP address of the servers that you manage. But for our case, we're going to set it up as 0000 with a net mask of 0, which is pretty much let anybody talk to your database. So that's not the best security choice. Once you deploy your app, you're probably going to want to lock this down to prevent unauthorized access to your database. So you can see a close-up view now of some data that I've created. So I have CST339. I have a collection called orders. We're going to add users later, but for right now, let's just ignore him. If you want to add a new record, you can choose here, Insert Document, and then we start typing. Now let's go ahead and add an item here. So I click the Insert Document, and you can see that I'm presented with an ID number. Then I start filling in the field names and the values that go with it. So order number, NO, I'm going to use for the first field name because I'm matching exactly the same properties that I did with the previous database. So order NO is what I used earlier. I'm making a string, it's a random number. The second item is product name. So clicking the little plus sign, and then I'm going to fill in something such as a gallon of seawater, for example. Well, then that's a string as well. Let's do the third one now. So the third one is price. The third field can be a different data type. So I want it to be some kind of a float. So is there a float there? I think there's a double. That's probably a good one for a decimal point. And then lastly, I want to have the quantity, which I'm going to set to be an integer. And it looks to me like int 32 or 64 are choices here. When I'm finally done, I click the insert, and it will be added to the database. Now you notice we had no constraints on what field names we need to use. We just make them up every time we enter some data. So there's no column headers here to guide you as to what kind of data you're interested in. Now let's scroll down to see what I've created in earlier video part. So I got a banana bender. I have a refillable toothpaste tube. I have canned laughter and left-handed coffee cups and fake news subscription and a pre-staled bread, placebo pills, and then it looks like a gallon of seawater. So you can see the theme here is I'm trying to come up with some very useful things to sell on my site. So now I have filled my database, at least the orders collection. Now it's time to return to our code, and we're going to extend our application to add MongoDB. So the last project we made was version 4.4. I'm going to copy that and make it into 5.1. So copy and paste, and we'll rename it. So after duplicating the project, I need to go and change 3 values. So open up the main Java folder and look for the item that says topic 4.4 application and rename it to 5.1. So we refactor it. Finally, we go to the POM file. We open up POM. Look for 2 instances of the string of topic 4-4 and rename it as 5.1. Once we've got all these changes, we are ready to work on the new version of this app. So now we're going to undo a lot of work that we did in the past tutorial. We're replacing the MySQL database with Mongo. So I'm going to stay right here in the POM file and go see what we had for MySQL. So let's see. This here was a dependency called MySQL connector. And the next one down is JDBC, which is the Java Database Connector dependency. So both of these are required to talk to MySQL, and I'm deleting them now because we no longer need to talk to MySQL. As soon as I save this, you're going to see that all kinds of red marks are going to show up in our code because we have references to those libraries. So we have some refactoring to do to make this work properly. So now I need to go find the dependency that will make Mongo work. So what I'm looking for is called Spring Boot Starter Data MongoDB. And somewhere on the first page of search results, you'll find the MVN repository page. And I'm going to pick the most recent, which in my case is version 2.6.3. I'm going to copy the page that's here, and you can see that it says it's copied to the clipboard. Let's return to the POM file and go ahead and paste it. This here is going to allow us to connect to a MongoDB. So I'll save it, and then I'm going to go ahead and do the refactoring now. The first reference to our database is found in the application properties file. So we're opening up the resources folder and the application properties. I'm going to select everything and delete it. So now I need to go get a connection string to make this work so I can talk to my app. So I'm going to go into the project that I created earlier, and I'm going to go find the connect button. So I am clicking this connect, and it says here connect to your application. And down here you should see a string. So this is the connection string that we've got here. So I'm going to copy it. And you're going to notice that the word password is here. It does not reveal the password. You have to remember what you created earlier. So other than that, we're just going to copy the code, and let's go back into our Java app. So here we are back in the Java app, and I'm going to paste it. Let's see. I think I need to show word wrap so I can see the whole thing. There we go. And put in your password right here. So after the connection string, we also need to tell it which database we're talking to. So you get some type ahead help here. So let's type in spring.data.mongodb.database. Once you got all that, you say equals, and then the name of the database that you just created. Mine is CST339. You can see that my database is called My First Database. My database is called CST339. The other item that needs some help is the first line here. So this connection string is, I believe, formatted correctly, but I didn't tell Java that it is actually a connection string. So we need to put in front of it spring.data.mongodb.uri. So that's the URI, or the Universal Resource Indicator, and that will tell us where to get our stuff. So I'm going to save this. Now we're going to modify the first class that talks to the database, which is our order entity. Let's open it up. Now there's some stuff at the top that we imported from MySQL, and we're going to delete those dependencies, those includes. We have all these labels at the top of each one of our properties, such as what the column name is. So let's go ahead and remove everything that is an indicator of which column name we're talking to, because Mongo doesn't have any more column names. So now we're left with just the names of the properties. The next item in the list is the int value for the ID. So Mongo uses a string for an ID value. In the previous database, we were talking to integers. So I am removing long and changing it to string. As soon as I change the property at the top of the page, everything else breaks. So the constructor and the getter and the setter for various properties all the way down the page. So wherever you see the word long ID, it needs to be changed to string ID. Once you've got all those changes made, push the save key, and hopefully all the errors go away. So I'm looking at the right column here, and I see no little red marks, so apparently things are good. Next, we need to add some identifiers so that this entity can talk to the actual collection that we made. So the first property is for the class itself. This is going to connect to the document. The document is called orders. The next item on the list is ID. So we put @ID above it as an annotation, and we have to import the correct library to make that happen. This will let us know that the ID is generated by the system. We can impose other order on our database, such as the word indexed. So indexed allows us to make the database more efficient. And we are going to impose a unique value for the order number. So that's the syntax you need, is unique equals true. I'm also going to specify that each product name has to be unique. So that'll avoid confusion in the database if we keep those unique. Also, indexing is a great way to make your database more efficient. So when you're doing searching, things work much more quickly with indexed values. Now the other two properties, they can just stay as generic as values that they were before. So no special annotations on price or quantity. Okay, let's browse down the page to make sure that no errors exist. The entity is ready to go with MongoDB. However, there's still a whole bunch of errors. I see X's all over the place in my other classes, so we'll get to those now. Let's take a look here at orders mapper. What was that all about? So this thing here was talking about row sets and row numbers and the ability to work with the entity. We don't need that with MongoDB, so let's just delete the order mapper. I see some more errors down here in the data folder. So we have the orders data service, and we've got a few other things. We don't need the fake guy anymore, so let's just take him out. We're no longer interested. Now we're going to notice that changing this ID from an integer into a string is going to cause a ripple effect down the list of all of the classes that we've made. Let's go look inside the data folder and see what's going on. I'm going to start with the orders data access interface and see what we did there. So this is the interface that tells us of all of the things that our data repository is able to do, such as get one by ID, delete one, search for one, etc. Now we've got some problems here because if we leave this as a long, it won't talk to the database very well. So we're going to change everything from long ID to string ID. So I believe there's like 4 or 5 things on this page that we need to update. First of all, the get by ID has a long. We're going to change that to a string. What's the next one down? It looks like add one has a return type of an ID or a long. Let's change that to a string. Delete one using the ID number. Change that to a string. And then finally update one also requires a string instead of a long. So double check all this to make sure that you see string where there used to be long. Okay, so you look at, and we're creating more errors as we change things. So more red X's on the left side that we need to take care of next. So we might as well really mess things up. Let's go into the services folder, and I'm looking for the order business service interface. This has a few things that are listed as long ID as well. So I'm searching for long ID and replacing it with string ID for, it looks like 3 or maybe 4 cases along here. So change all the longs to strings and save it and see what happens now. More red X's appear. So let's look over at the left column here. I see the orders fake DAO now has a red box on it. Let's open that up and see why it's got a problem. It's because we have get by ID using a long instead of a string. So we could go and retrofit all this, but I really don't need the fake one anymore. So I'm going to right click and delete the orders fake DAO. It's probably not as useful as the real database. Also, we have another item here that talks strictly to the MySQL. It's orders data service Java. And as you can see in this, there was a whole bunch of SQL statements. I don't think we're going to be needing that as well. So let's go ahead and right click and choose delete. And we will keep them as an older version of our app. But for this version, we're deleting them and going strictly with Mongo. All right, let's attack the next one down here, which is orders repository interface. So this thing here is using the CRUD repository, which allowed us to talk to the database without writing very many commands at all. There is an alternative to the CRUD repository. It's called the Mongo repository. So let's rename CRUD to Mongo, and you notice we have to do another import. Let's look at the libraries that were imported. So we had the Mongo repository just added, and the other which was from MySQL, which no longer works, so we'll just delete that. So we're going to use Mongo repository, which has all of the same commands as the CRUD repository. Isn't that nice? So we don't have to rewrite all of those SQL selects or anything like that. So the next item down, I'm going to rename this custom search. This is the searching for the product name. I'm going to just leave it as find by product name. Then we have to specify a few more details to make this work properly. So in an annotation just above this line, we are going to tell it how Mongo should handle a query. So it's @query in some parentheses. Okay, so this syntax can be really tricky if you get all these boundaries wrong. So let's follow it closely. So we're going to put quotations and then 2 curly brackets, so an open and a close. Then inside of the curly brackets, we are going to put in a name of our field that we're searching on. So product name. So single quotes, product name, a colon, and then 2 more curly brackets. Now inside of those curly brackets, we're going to specify how product name should be matched. So we're going to use a regular expression to find it. Lastly, there's going to be a comma and some trailing information which will give us options for making this case insensitive. Okay, inside the first item, we're going to put single quotes and $regex, then a colon and a question mark 0. Okay, so don't get mad at me yet. Let me explain it. So first of all, $regex means we're going to use a regular expression. So anything that does a pattern match on the string that we provided. So what is question mark 0? Well, question mark 0 refers to an item that is being sent in as a term. And as you can see below, there is a parameter called search term that we're expecting. So question mark 0 responds to or corresponds to search term. The last item that we're looking for is for options. So we'll put in a single quote, a colon, another set of single quotes. $ options goes in the first quote, colon is the middle, and then an I. So I stands for case insensitive. So it'll take capital letters or lowercase letters and find matches on both of them. Now if I look carefully, I think I have left unbalanced curly brackets. So I'm going to add one more. So I'm looking at the curly brackets and they do not balance, looks like. So this one here is not supposed to be in and this one is. So this means that this whole thing is treated as an object inside of another object. So kind of confusing, and if it were on separate lines it would be easier to see, but this will prevent errors later on. So this here is a search that you would normally learn if you were in the MongoDB database course. So I'll just leave it here and take my word for it that this is a search for a wildcard search on a string. Case insensitive. There's one more detail that I noticed here. At the top, it says long. So long was the ID value that we're searching on, and the entity no longer uses longs, it uses strings for its ID. All right, so all of that is going to change us to connect to the database on the Mongo server, and we should get the same results using the same kind of functions. Okay, back to the side here. We're going into the orders data service for repository. Let's see what we can clean up there. All right, let's look at the top first. We have some imports that we asked for, and they're no longer part of our project dependencies, so we'll manually delete them. So anything that refers to databases like JDBC, we're going to get rid of. Then we have the data source, as you can see in our properties of this class. We can get rid of that. We're still going to use the orders repository, but we no longer have to talk to the SQL. Now it's my job again to go down and find all of those nasty IDs that were listed as long ID. I'm replacing them with string ID. So I think there was about 5 here. So this has to be changed because of that interface that I modified just a few minutes ago. When we're done here, we should not have to modify any of the actual method names, such as update1 or delete1. They all still work the same. It's just instead of using an integer or a long for an ID value, we're using the string that comes with MongoDB. Okay, I still see one nasty little error. It says return 0. So if add 1 fails, it says in the previous edition of our program to return a 0. Well, I can't return a 0 because that's not a string, so I think I'll just return it as a null value, and that is acceptable to the compiler. Okay, I'm going to scroll back up through here. I still see one that's not right. So I renamed this thing. Instead of find product name containing upper or lowercase or whatever, I just set it as product find or find product name. So if I make that match to the interface, then the error goes away. So the interface had this name, which was find product by name, and that seems to be working. Let's take a look at order business service. It seems to have a problem. We'll open up him and see why. All right, so let's go all the way down through the list. We're looking for anything in this class that has the same pattern we did before. Long ID no longer exists. We're looking to change it to string ID. So based on previous experience, I'm looking for about 4 or 5 occurrences where we find string ID. When you're done, save the file, and hopefully the red X goes away. If not, then just scroll back through to see if you missed one. Now let's go look in the controllers to see what's going on there, because we have some refactoring obviously. So the first item I'm going to pick on is the REST controller. So let's open up him. We're going to look for the same patterns. So wherever you see an underline, there's probably an issue with one of the return types or the ID values. So you can see this one here says we have a problem. And it's not because of the line that's listed where it says service add one, it's because of the return type. It's expecting to have a long here. Tell it that we're expecting to put in a string. Let's see what else we have. So this one has a long, change it to a string, and the one below. So now let's move up one more level. Instead of the entity, let's go to the order model. And guess what we're going to do here? Same process. So you see longs, change them to strings. So we change the property at the top of the page from long int to string int. We have to change the constructor so that it accepts a string value. And then all the way down the page, there's probably a getter and maybe a setter that goes along with the ID as well. So those are all strings. So now check through any of the other classes. You may have missed one, or I have missed one, but these should start to see that all of the red X's go away, and it looks like mine are looking pretty clean. I've got one left here. What's that say? It says spring config. And so the data source needs to be updated, and then I think we're done. So in the config file, we no longer have to talk about a data source in the same way. We're no longer using MySQL, so I'm going to delete the data source. And the getData service no longer needs that as one of its parameters. So this hopefully will work. If I am so lucky, it will run the first time. So I'm going to try it out. I'm going to right click and make sure that I'm running this project here. So I'm going say run as and then the Spring Boot app. And let's see if anything goes wrong. So let's bring up a web browser and go back to our local host. So let's see, I was on localhost 8080 before and /orders. Wow, look at that. I'm going to zoom in and take a peek at these beautiful IDs. So you can see that I have connected to the database. I have more useless stuff now, such as banana benders, rather than the other product line that was in my SQL database. Let's see if we can try the admin. And it looks like the admin function is working as well. I probably could do an add. Okay, so we got all the products here. Let's see if we can search for a product. So I'm going to search for something like BAN. I believe that we have a banana, and sure enough, we get one. Let's do another search for just the letter A, for example, and that'll give us a few more. And once again, you can see that all of the product IDs are now reflecting the fact that they are strings coming from Mongo instead of from the other database. Now we had another type of app, and that was the SPA. Let's see if the single page app works. So I'm going to search for an A, and it looks to me like the REST service is working correctly. Let's go and edit somebody to make sure that works. Let's try the banana bender. I'm going to edit that one, and let's change his price into $50 instead of $5. So we're going to see this number here change as soon as I click OK and search, and sure enough, we got a 50. Okay, we got ourselves a Mongo database. Hooray, we did it. In the next steps of this tutorial, I'm going to show you how to handle exceptions so that way we don't crash our app and leave these horrible white label messages on our screen for our users. So we're going to do exception handling coming up next.